So in our fourth video, the fourth topic of the year, we're going to be looking at determining the equivalent forms of irrational expressions, limited to numerators and denominators that are monomials, binomials, or trinomials. So our numerators and denominators are only going to get so big, but we need to find equivalent forms. So what is an equivalent form? Let's say, for example, that we have x squared minus 3x plus 2 over x minus 1. This is a rational expression. It's rational, like the rational numbers that can be written as fractions, because it's one polynomial over another. It's an expression because we do not have an equal sign. So if it's not equal to anything, it can't be an equation, it's just an expression. So what are the equivalent forms? Well, if we were to factor our numerator here, and here the equal sign is the one that we have added, it's not part of the original question, so it does not turn it into an equation, but our numerator can factor. So then we can cancel that common factor of x minus 1, and we are left with x minus 2. So this equation or expression simplifies nicely. So this is the equivalent form. But the big thing we have to watch out for would be that division by 0 is not allowed. So these forms are only equivalent when x is not equal to 1. When x equals 1, our final expression here is perfectly well defined. We just get y equals negative 1. And the expression is equal to negative 1. Whereas with our original, when x equals 1, we end up with 0 over 0. And division by 0 is not defined. So if we were to graph this one, we'd get a line that looks exactly like x minus 2, except with a hole where x equals 1. That's when you graph the version on the left. The version on the right wouldn't have that hole. So they are only equivalent when x does not equal negative 1. So that is the kind of thing we're going to really have to watch for. So we're going to be looking for common factors to simplify, which is easy enough given the background that we have in that so far. But we're really going to have to watch for denominators that we have to cancel out when we're producing our equivalent forms.